Now, I mentioned signals already a few times, and the relevance of it here is not just building this profiles and observing who is browsing your website, but also that you can react and adapt the website depending on who is browsing. And here's a little demo of what that might look like.
Hi there. Today I want to talk about agentic browsing. An agentic browser is a browser you just tell, go to this page, fetch this content and summarize it for me, and it does everything while you sit back, relax and have a coffee. Now, this is great for the users but raises some questions. What if the website's business model relies on human interaction? What happens to key metrics like engaged time and click-through rates, which traditionally assume humans clicking or not clicking on things? In this demo, I'll show how a website might intelligently adapt depending on who is browsing it, a human or an agent. Behind the scenes, we'll be using Snowplow event tracking and Snowplow signals. This is a great combo because not only do we make the website adaptive, but we also get complete analytics. What were the individual page view events, and which parts of the sessions were driven by the human or the agent? Let's get started. For this demo, I've built a fictitious resource dedicated to unusual sports. You can see it has a bunch of articles on made-up competitions which may or may not have been written by AI, but that's beside the point. At the top I've added a little widget that tells us who the website thinks I am. This obviously wouldn't be present on a real website, but for the demo it's really handy to see what's going on under the hood. You can see I'm classified as a human at the moment. This will remain the case as long as I browse the website normally. Notice that as I navigate from one page to another, I move the mouse, scroll as I read. This is what humans do. All of my actions generate Snowplow events, and the website's backend uses Snowplow signals to build a real-time profile of how much engagement I've shown for each page visited. Then it comes up with a probability of me being a human. Now let's see what happens when I ask the agentic browser to navigate the website for me. Here's the assistant. Visit all the articles and summarize them for me. There you go. At this point, the browser takes control of the page. We'll speed up the footage a little bit as it prepares for the task, but already you can see it approaches browsing very differently. There's not much wandering or scrolling. The agent just processes the content of the page and it knows where to go. After the agent visits a few pages without exhibiting any human-like interaction, the website flags it as not human. Now, this is where things get interesting. Since we detected the agent, we can choose to render the content differently. For example, we can shorten the article to just the summary and try to force the human to intervene to see the full content. In other words, we set our own terms for how the agent intermediates between our website and the user. But we don't just want to pay attention to the transition from a human to an agent. We also want to know when the human returns. For this, I've set up a Snowplow Signals intervention, a real-time trigger that we'll see what happens. I'll take back control and once again browse the website normally. Once the website is certain that a human is back at the helm, it introduces me to its own agent, an expert on unusual sports. Would it be able to help me better than a generic browser agent? Probably, although this one is just a mockup. By now we've seen a few ways that a website might adjust to agentic browsing. But you might be wondering, can we quantify how much of that is going on? Can we analyze the data? The answer is yes. Because we are using regular Snowplow events, all the data will be in the warehouse. Looking at Snowplow UI, I can see individual page view events, supplemented with the classification score at the moment. And because all the mouse movements and scrolling activity is recorded, I can adjust the logic and compute a better score in my data model post factum. That's all for today. Thank you for watching.